So we go ahead and end chapter 8 with this idea of ordering exponents. Ordering integers. How do we know when one integer is bigger than another? And so we'll have two approaches to that. We'll use a number line approach and an addition approach. And we've done this previously too before when we first started talking about way back at the beginning of the class about how we know. It's almost such a simple question you've never thought about. How do I know if a number is bigger than another number? And one approach with integers is through the number line approach. Whatever number is on the left side of a number line of another number, right, it's a smaller number. And that's it. That's the number line approach. You're looking at it here. -3 is to the left of -2. -4 is to the left of -1, right? Numbers on the left are smaller. The other approach is the addition approach. And this one was made you think a little bit more. And remember, we know one number is smaller than another number if we have to add another number to one of them, right, to make it equal to it. So we know A is smaller than B if I have to add a number to A to make it equal to B. I have to give it a little bit of something, right? -5 is smaller than -3 because I have to add 2 to it. And so that's the idea of how we know if a number is smaller than another number, right? We can think the same way. We know a number is bigger than another number, right? And we have that interplay with it. And so -1 is smaller than 2 because -1 plus 3 equals 2, right? 3 is a positive integer. We're adding it to -1, and that makes it, so that gives us the reason why -1 has to be smaller than 2 because I had to give it something. And then thinking about greater than symbol, if the integer A is greater than the integer B, written A greater than B, if and only if B is smaller than A. And so you'll see the interchange. If B is smaller than A, then I know A is bigger than B. So again, we have that argument, and we can also carry that with the less than or equal to the same argument holds. We end with these examples here. What numbers, or a number line approach, you can see -13 is the smallest. I know -8 is smaller than -5 because -8 plus what equals -5 has to be a 3. So I'm giving -8 something to make it -5. So that's how I know it's smaller. And then we end with these properties here. And a lot of these again come back to algebraic reasoning later on. If A is less than B and B is less than C, then we know that A has to be less than C, just following the order like a number line approach. We can add the same number to both sides. The inequality stays the same, right? When you multiply both sides by a positive number, the inequality stays the same. And then lastly, if you multiply both sides of an inequality by a negative number, we have to flip those. And so, for example, we know 2 is smaller than 4, for example. And then if I multiply both sides by -2, I get, -3, I get -6. If I multiply this by -3, I get -12. And when I multiply both sides by a negative, to keep the statement true, I have to flip the signs, right? So that becomes the thing. In order to keep the statement true, you flip the inequality signs, right? Oh, it's not the wrong way, sorry. -6 is bigger than -2. Flip signs to keep it the same.